not just, let me point my telescope up here and take an image, but really think about what it is I'm imaging. And so to that, I really appreciate and thank you, Rick. So without any more delay, I'd like to introduce with all my heart, Dr. Rick Nolthenius.
Well, thanks, Roger, and I got to thank you because one of your students now is Will, who is taking Astro 9, and he is like over the moon with you and what you've taught him, and he's just like eternally grateful. And he's my best student in astrophotography. Nobody else even comes close. So these things do carry on, and that's the rewards of teaching. So I said 1963, I actually got interested in astronomy because of a partial eclipse of the sun that went across Maine and, nowhere near California, but we did get a little bite taken out of the sun. And of course, at this time, I was like the firstborn of my parents, and they didn't particularly want me. And people were kind of crazy. I said, I don't know what's good, but this ain't it. But I saw this blurb in the paper that said there would be this eclipse, and here's exactly how it would start, when it would start, what it would look like. And I got some film, and I taped it together, and I looked, and it happened just the way they said. I said, my God. And I was trapped. I was enthralled. And so I've been interested in astronomy ever since. I joined the astronomy club in our high school. We did a whole bunch of cool adventures there. We'd drive out to the desert to do lunar grazing occultations, back when those were a big deal in the 1970s and late 60s. Then I went to University of Arizona, and I started majoring in astronomy, but that was when the Apollo program was ending, and the astronomers actually got all of us young people in the room, and they said, get out while you still can. Not 1 in 100 of you is ever going to be able to be an astronomer. And I kind of took that to heart and thought, So I cast about. I was an architecture major for a little bit, and anyway, I ended up graduating in mathematics. So that was okay, pretty general. And then I went on and did thermodynamics engineering for a master's. And that has served me well, especially recently. And then I went on, I worked in the space program at General Dynamics for a couple of years. I was a thermodynamics engineer. I was the designer on their entry into what became eventually the International Space Station. We didn't win it, but not because my part of it was no good. Actually, my part was fine. Anyway, I won't go into that. But I still wanted to do astronomy, and I kind of got a little frustrated with cubicle world and the efficiency of having codes that were already there and inputting stuff and getting them out and then writing a little memo and then doing it again. And it wasn't a whole lot of creativity, and I thought, I just want to be an astronomer. I just want to do astronomy. So I applied to Stanford, and I got accepted, and I started my PhD at Stanford and applied physics, worked in solar for a while, and then for reasons I definitely won't go into, personal reasons, I had to go to LA. I had to move my life to LA, so I did. And I finished up at UCLA, but I did get a PhD in astronomy there. Went on and did a postdoc at Stewart Observatory, again, which is where I guess we almost crossed paths. With Simon White, I was his first grad student. He's now like a pretty big name in cosmology. And then at the end of that, I could have either joined my buddy, who was part of he and his graduate student advisor, he was a double major in optics and astronomy, John Hayes, and they formed a little company called WICO Corporation. And their idea was to use interferometry to be able to build great big mirrors accurately. And that was fine, but what was quadruply fine was that disk drives were coming online, and that's the technology they needed to do that. So their company got bought up, and John ended up with I don't know how many jets and whatnot, and here I am. I'd chosen, do I want to work for WICO? This is when it was just a little teeny, I would have been like employee number 12 or something, or 10. Or do I want to stay in astronomy? And so I
But Rick, this way you
Chris
don't have
is-
to worry about helicopter or jet maintenance.
Well, that's true, yeah. But I could be flying into Bonnie Doon for star parties instead of driving up there. Anyway, career college has been good in many ways. I've met a bunch of great people like Kirk and Chris, and you're going to see Chris later in this presentation here. Anyway, so I've been there since 1986. And I've been interested in occultations, though, all the way back to the late 1960s. So David Dunham, past president of the International Occultation Timing Association, IOTA, got interested a little bit before me, but we both got interested together, and so he and I have been kind of working together and crossing paths for a long time. First lunar occultations, then lunar grazing occultations, and then now that the Japanese have mapped the moon so completely, there's not a whole lot of value left to be done there. And then it became asteroid occultation. So that's now what I do and what I'm going to talk about tonight. So without further ado, let's start. If it will listen to me.
Sorry, folks.
While he's working on that, I have
Oh yeah, if you got a question.
I saw in the sky telescope. There's a
What's that?
Repeat the question for the microphone.
Okay.
There we go.
okay. I saw in Sky Telescope there's an asteroid occultation in southern Florida next month. Are you planning to travel there for that?
Somebody will pay me. Yeah, Betelgeuse is going to get occulted by a little teeny asteroid.
Oh, that's what it is.
And of course, Betelgeuse is like one of the very few stars large enough that you can actually image the disk.
Yeah.
And it won't be just like a blink out and blink back on like most of these little. So be able to do a little bit of eclipse mapping, which another friend of mine, Keith Horn, kind of pioneered. He's been at Cambridge University now for a long time. Yeah.
Can you, in the most general terms, state what the purposes and practical aspects of doing all this work?
Yes, that's the subject on my first couple of slides. So, what can you do with watching occulting asteroids? It's kind of fun to see things happen in limited time because so many of the things that we look at in the sky just sit there. But here you actually get to see something happening. And the fact that asteroids move so slowly through the sky and that we can measure time down to tiny, tiny, tiny fractions of a second. You can timestamp every video with 1/10,000th of a second precision. That turns into a few meters, if you're lucky, on asteroids that are 100, 200 million miles away. So they're by far the most accurate ways to do astrometry, the precision measuring of positions, which are essential if you want to get good orbits. Now there's reasons to do better orbits for asteroids for a lot of reasons, but there's also even practical ones like some of the targets that Kirk and I have gone after have been Earth crossers. And someday they're going to cause trouble. So we're part of the planetary defense team. So, Bruce Willis has nothing on us.
Go team.
Yeah, so thanks to the Gaia mission and Gaia Data Release 5, we have incredibly precise positions on stars, millions and millions of them, and some on asteroids. However, look at the precision that you can get on an asteroid, way better than you could get any other means, if you've got good timings. Now, you might wonder, well, wait a minute, where did all this come from, all this shading? And well, you can also do photometry, so we don't do that with asteroid occultations, but you can do it, and it ends up giving you a model for the reflectivity and the shape of the asteroids. However, those solutions are not usually unique. There's many that can work. So what's needed is asteroid occultations to decide amongst those many solutions that fit the photometry, what's the right one.
So there's usually different scopes that are all over the place observing the same thing. Is that how they get different sides of it from the different photographs at different locations in the world that are looking at the same object?
Yeah, so here you can see Bill Gimple, Ted Swift, who's up in Davis, Mr. Liu, who's joined recently, and Cupertino, Kent Osaki, and then me and Kirk Bender. We all got this one. Sometimes you go after really hard ones. Kirk and I tend to go after hard ones just because there's more of them. And then there may only be 1 or 2 chords. 1 or 2 chords is not great. 1 chord, you can't tell much. 2 chords, though, already tell you, that gives you 4 points on an asteroid, and it pretty well fits. It determines an ellipsoid. So you can get good astrometry even from just 2 chords, which is why I applied for grants. I've been applying for grants and getting more equipment, and the first person I equipped was Kirk, because he's got lots of great observing skills, and he takes the time, and he. Okay, I'm going to tell you the batting average this year so far. Me and Kirk. Who do you think's winning? Kirk. So I've got 43 events. Kirk's got 43 events. But I've also got 6 screw-ups that were my fault. Kirk's got 2. What's that?
This year, 43?
This year we got 43.
Didn't realize it was 43.
Yeah. We're going up and away. So anyway, the photometry is called dammit modeling, and I can't tell you what this means because it's so memorable. That was enough. Okay, I can remember that. Yeah. Damn it, right. So in the hands of careful amateur astronomers, all of you can do this. You can get far more precise astrometric orbital positions. You can discover new moons. So Kirk and I have been involved in that as well. Produce high precision shape determinations. Now if you discover a new moon, then you've got the orbit, and then you can plug it into Kepler's 3 laws, and boom, you've got the masses. But if you got the masses and the sizes, now you got the density too. So now you got a good handle on what it's made out of. So for one of these asteroids, Psyche, the average density is 5 grams per cubic centimeter. That's 5 times the density of water. So what's happened now is all kinds of commercial people have got dollar signs in there. Oh my God, maybe it's made of gold. We gotta go get that asteroid. You guys have all seen Don't Look Up, right?
Oh, yeah.
Okay. So there you go. Anyway, yeah, we can timestamp video frames. You'll see them down to a 10,000th of a second, and it gives you incredible detail. And there are space missions that go out to these asteroids, and they put out the word, and there are professional astronomy groups that make sure that we get the predictions for where these paths are going to be as well as possible, so that we can go out and get them, because they need a good orbit if they're going to. And they also need to know if this target that we're going after, if it's got any moons, like the Lucy mission, which is going out to the Trojan asteroids in Jupiter's orbit. What if there's moons around some of these they didn't know about? It's like you're coming in to take and then you get. So, yeah. I mean, discovering moons is a good thing, not just because you're trying to avoid danger, but. So the setup for all this is actually, fairly humble looking. There's a Celestron C8. There's our Wattec 910HX video camera. Now, you want to get as much light per pixel as possible so that the signal really shows up. And so we use a focal reducer. It's unfortunate they don't make these focal reducers anymore. f3.3 focal reducer. Celestron used to make them, Meade used to make them, and they don't make them anymore. Their optical quality wasn't, perfect, but we don't need perfect optical quality. We just need to get the light down to, as few pixels as possible to boost the signal. So they're great. I mean, I had that one donated to me, but like the third member of our team, Carl von Annen, who used to run the planetarium up at De Anza College, I couldn't give him an f3.3. He's got an f6.3, which hurts his ability to get some of the events. I built an OCK box, I call it, my OCK box, and I built another one for Kirk. And it's basically got a battery in there. It's got a video time inserter, these are built by the IOTA group. And basically what they do is they take the time signals, the 1 PPS time signals that come down from the GPS satellites, and it stamps them on every frame. The remote to control the camcorder. This camcorder here is not looking at anything because it's really just a recorder. It's not being used as a, it's just taking video that comes in from here, is what I'm trying to say.
Capture device.
It's just a capture device. There you go. And then, you know, various stuff lying around. And I always like to deploy out of the back of my RAV4 because then I don't have to set up a table.
So don't go any further. So you've done 42 observations.
43. 42 is the magic answer to the universe, but 43 is the number of events so far. So far. Kirk and I are going to try another one tonight.
Oh, yeah, that's what I was wondering.
How often?
Does it take and
Well, it depends on your equipment. We can get down to 14th magnitude stars if we have moonless skies that are really clean and dark. 13th magnitude, usually not a problem. 12s look bright. 11s are, you know, incredible. But of course, those are rare.
You know what's going to happen? You know the time, and so you find the star, and then you set everything up, and it happens within a minute or two or an hour.
The entire event lasts typically a few seconds.
Oh, okay.
Yeah.
Yeah, but how much before and after? Is there like an hour set up and an hour after?
Kirk likes an hour. I usually, I don't know what it is about me, but it's like I'm always busy, and you know, I cut it down to the nub, and I figure, you know, nothing goes wrong. I can turn off the engine to my car and be on target in 25 minutes or 20 minutes. But sometimes things do go wrong, and that's why I've got 6 screw-ups, and Kirk only has 2 this year.
Because he takes his time.
Yeah, he's better prepared when things go wrong. But I have gotten some important events that Kirk has not gotten, so I got to defend myself a little. Yes?
So how do you do the pointing on that scope, since the hand
Ah.
controller isn't going to do it for you?
Well, no, this Celestron C8 is great, so it'll do 2-star align. You got to kind of learn the first names, the Arabic names of a lot of stars.
Yeah, I've tried that. Go on.
Yeah, so, you know, usually I try and go for Polaris and then some other first magnitude star. I certainly know all those and some of the seconds. And you go to it and you center it in your eyepiece. And then the other thing I do is I make sure when I center it, I approach the center from the same quadrant. So I take up slack from the same direction for both stars. And I go to another one, should be far apart. Don't take 2 that are close together because then the matrix solution will be almost degenerate. Far apart, and then you tell it, okay, go to this RA and deck. And it goes there. And it's usually within half a field of an eyepiece. We use 32 millimeter Q70 eyepieces from Orion, wide field of view. And it hasn't really been a problem. So yeah, with this, there's a chart there. There's software called Occult Watcher. And Occult Watcher you can just push a button and say, make a C2A chart for me. C2A is planetarium software that'll plot star charts. And you can specify in that interface, okay, I want to see what it looks like in an altazimuth scope, and I want to see it a half an hour before the event. And it'll take me to that star, and I can see the altitude and azimuth, and it'll have the right orientation. And from looking at my chip, you know, after an event, I can figure out what's the field of view. And so I've made, you know, a bunch of different, there's like the circle for the eyepiece, and then there's a smaller square for the chip where the data recording is. And the whole goal is that you don't want to have to be inverting and perverting and going, you know, to like, okay, well, do I have to turn my head up? Do I have to illuminate this from the backs? You guys know about all that. Yeah. So you don't want to have to. I used to do that back in the old days. So I'm surprised I got as many events as I did. Now I'm, you know, 70, and I don't want to have to do that. I want to look at the chart and I want to see, okay, where's that pattern? Okay, I see it. It's pretty good. It actually works pretty well.
You're looking at kind of the star field to try to match, like a plate solved in your head.
Yeah. You kind of look. What are the?
Solving from the diagram.
Yeah, but, you know.
Yeah.
Manually.
I I don't know if I have, I don't have one here. I should have put one in. Anyway, let's go back here. So yeah, it shows the eyepiece, and so I say, okay, what do I got here? Oh, well, this star, and this star look bright. Huh, that's a equilateral triangle. It's about the same size as the eyepiece. Look for a pattern. Oh, here's a double star. Okay, let's look for that. Something unique.
Yeah.
You guys know how that works. You star hop.
So you actually do the alignment by eye before you put the camera on the back of the scope?
Yes. Yes. Yeah, I don't trust it to just put in the camera and then go to, because usually go-tos are not quite. I mean, the field of view for these Wattec cameras is tiny.
How you do the pointing.
Yeah, no, I know,
You know what you're looking
I do it by eyepiece, and then while it's sitting in the eyepiece, I will leave it there while I go and I get the rest of the optics about ready to plug in. That'll take another few minutes, and then I go back and I look and I see whether it's drifted. Sometimes it has drifted. And if I just mindlessly put it in, then it's like I can't see anything. I've done that once or twice in the past. I don't do it anymore. You got to get your workflow down perfectly, otherwise there's so many ways to screw up. I was telling Kirk, we ought to write a book on all the ways that you can mess up. Because there's
Some observers, they do bring laptops out and they have plate solving on their laptop computer, and it'll tell them exactly the RA and the depth.
readily available, yes.
yeah.
Then they're using the camera, right?
But I don't like bringing my laptop is my life. What like I don't want to bring my laptop anywhere except leave it at home.
Get an extra one.
Yeah, I could, but I'm happy.
Back onto the camera again. It's kind of like a two-part question. First part is that a black and white or color imager?
It's black and white.
Okay.
And why do we use the Wattec 910HX? Because it's still the most sensitive camera out there.
Sensitive in terms of...
Lux, .00002
It's got
lux.
the largest pixels,
Really?
like US pixels, or what?
No, it's not the largest well, it's a half-inch, and it's, what, 720 by 480? I forget. Do you remember, Kirk?
Okay. Half-inch sensor.
So it's not high resolution, but we don't need high resolution. We just
Which
need
one is
okay resolution.
Lots of photons.
Yeah, what we want is not to fumble photons when they come in. If a photon comes in, we want to see it.
And it's cooled.
Yeah.
No.
So you want lots of dynamic.
Only when it's cold, only in the winter.
So how much noise is there on it?
Yeah.
It's an old chip.
Well, actually, the software that we use for reductions now, just very recently, has the ability to put in dark frames, dark video, and flat fielding. And so, but I haven't quite learned it yet. And yeah, that'll improve. But there is in-camera firmware that can get rid of hot pixels. I think it does a median around where you have a hot pixel, and it puts that in there.
This is a relative measurement mostly, right? You're seeing a change. Even if there was an error, if you can see the change, then your measurements.
Yeah. There is one event that looked like it might be a moon. It was weird. But we can't be sure, because that was the whole reason that Bob Anderson, who did the software, I got him to put in all this new software for dark subtracting and flat fielding, because he was worried, well, maybe that dip was because it went around a little cluster of bad pixels. We don't know. The auditors who take this data from us and then make sure that it's bomb-proof before they send it on to the data banks at the Minor Planet Center can be pretty persnickety. In fact, we've kind of had some disagreements about that. I think data ought to be squeezed for all it's worth, and you should put a confidence on it and keep it in. It doesn't need to be 5 sigma. We're not trying to claim the discovery of a new particle, at the LHC. We're just trying to get a better orbit, and if it's almost certainly good, then why not report it? But anyway, I don't want to get into that.
Those stars twinkle?
Yeah, stars twinkle. You'll see light curves here, and yeah, they definitely twinkle. So if you're looking for something that's a really shallow drop in brightness, boy, you better have pretty good signal to noise. You better be on like the 35-inch, 36-inch at Mira. So Have you talked to Dan and Jean about the?
We
Well-
don't have anything to do with the big instrument.
Oh,
We're
okay.
the club. We're the amateurs.
You're the Mirror Club.
Amateurs, yeah.
Okay.
14 inches is the biggest we have.
Well, yeah, I'll talk about our mirror adventure and our upcoming mirror adventure, actually. But so some of the things that we do are more than just helping get better astrometry on this asteroid and that, main belt asteroids. It may not end up being of super high. I mean, there's 100,000 of them out there. They're fun to do. It takes me away from climate science, which is the other big thing that I do, and that's depressing. So I like doing these things. But sometimes we do things that are really important. So Phaethon is this is the source of the Geminid meteors. Geminid meteor shower comes from this object. It's kind of a transition between a comet and an asteroid. It's like a dead or dying asteroid, comet rather. It doesn't have any outgassing, but its orbit does seem to change some, and it's on an Earth-crossing orbit. So we want to keep track of this. We've got a space mission that's going to go out there. And it turned out just a couple of years ago, 4 years ago now, this little teeny asteroid crossed over a very bright 7th magnitude star. Very rare for that to happen. And so we got into it. 60 tracks were laid out, and astronomers from all over the country came out to man each of these tracks. Luckily, it went across one of my favorite places, Carrizo Plain, and frankly, that's the perfect place to be doing these. There's all kinds of dirt roads that nobody lives on, and they're flat and perfect. There's no trees. I don't know why more of the people didn't choose to go there. Instead, they mostly set up in the Central Valley. But Kirk and I set up in Carrizo Plain, and I was chosen to be right on what they thought was the best orbital solution. And it turned out to be right. So I actually got the event, and this bright 7th magnitude star went psh, psh, literally that fast. Yes, I got it. Right. I saw no fading. Looked like it was a pretty sharp DNR, about a 1/4 second. So let it record for another couple of minutes. Excellent. We nailed it. It's small. It's not very big. It's like a kilometer, 1 kilometer across.
So you're taking a movie when that happens, right?
Yeah, we're taking a
How many
video.
frames do you think is in that whole occurrence?
So for that whole occurrence, there was like 15 frames or something, 30 frames a second, and it was.
Okay, so
Well-
I just got the whole idea. You need the background of the bright star for this black, dark object going in front of it to take pictures.
Mostly, you're not seeing the asteroid.
Yeah.
You're watching the star behind it disappear.
Yes, yes.
Yeah. Sometimes, though, the asteroid's brighter than the star. Then you only get a little bit of a drop. Those are tough.
Are there many asteroids that are that bright, or that reflected?
There are some. If you're looking down your predictions and you see some, oh my God, there's Vesta going to do something. Oh, phew, that'd be fun to see Vesta. And then you look at the magnitude drop and it's like 0.01. You say, well, you can't see that, so forget about it. Once in a while, though, I did see an asteroid occultation in Mexico long ago. Pallas passed in front of a 4th magnitude star.
Pallas is big, right?
Pallas is big, and normally occultations that it does are going to be tiny because it's brighter than almost all the stars. But that one was different. That was cool.
Wait. Going back to the previous slide, with all those tracks,
Yeah, what's the separation?
well, how many of those were actually manned?
Most of them. I don't have the exact number, but yeah, most of them were.
A few hundred meters apart?
Yeah, like 100 meters apart.
Did they assign them to you and then, they don't?
Yeah, that was.
If they had a lot of people, they could order.
Yeah, and mostly Kirk and I decide where we're going to set up because there's not a whole lot of other. But for a real important event like this, then yeah, there needs to be organization because you want to get your data properly spaced. And you don't want everybody saying, oh, I want to go to the center line. And then, then it shifts a little bit and nobody gets anything. Yeah. No, there is temptation to, just want to max your odds and go to the center line, but it might not give you the best science. So that's our station. We had fun. This is July of 2019. We set up, actually, I used this exact same spot in the middle of nowhere because it was the perfect spot to see a grazing occultation. This is about 20 years earlier. It turned out to have more Ds and Rs than any other graze I'd ever seen. 24 Ds and Rs, and it was right at that spot. So it was a lucky spot. So okay, let's go here. It was right on where Kirk's station was assigned. So Kirk manned this station, and then I drove a few miles away. And unfortunately, the asteroid was small, and Kirk had a miss. But it was a valuable miss. Sometimes misses help you know where it wasn't. Yeah.
The grazing occultation. So you're saying that it got dimmer and brighter several times, indicating there was shape to the...
So lunar grazing occultation, you're seeing the mountains, the dark mountains on the edge of the moon cover and uncover the star.
Okay.
And if you've got a really accurate profile, or you think you might get lucky, you set up, well, where can I get the most timings? That's actually the most valuable anyway. It isn't just because I want to get the most timings because I'm driving out here and I want my reward. But no, yeah. Question.
How do you escape the off-road rule?
What's the off-road rule?
In Cruz Plain, we had a situation where one of the ranger people came by and said you can't park off-road. And
Well, we didn't park off-road. See, we're on road.
Well, when we explained the situation, she insisted that we have one tire on the asphalt.
Huh? No.
Have a spare tire and throw it on the...
Okay.
Yeah.
I've never encountered that. No.
Out in tearing up
Yeah.
terrain.
This actually is not in Carrizo Plain National Monument. It's just north of it. It's this area called California City,
Oh, yeah.
or no, it's California Valley, which is different than California City, which is somewhere else. California Valley, which is like basically abandoned, but sometime long ago they thought, oh my God, we're going to put housing tracts in here. We'll build the roads. People are going to flood in. We're going to be rich. But nobody wanted to come there because it was drying out and climate was changing, and so. But there's all these roads still there, and they're great for going out and doing astronomy. So yeah, that's Kirk's scope, table, gear. He likes to put stuff in his chair, and if not stuff, then himself. That's my new tent. Very cool. Cameras. Anyway, it's a fun night. So there it is. There's Phaethon doing its thing. So yeah, there's point-to-point scatter even for 7th magnitude stars, but it drops to 0.
So do you create those? You're taking the pictures, like the 15 or whatever shots, but who, what, where?
Who, what, where? Yeah. So you need software.
So you
And
have it.
we have the software. It's free. There are people in the occultation business who are very good writers of software, and there's several. This one, well, this looks like Pyote. Or it might be PyMovie. It's hard to tell because I did frame-to-frame integration. Pardon?
That's PyMovie.
Looks more like PyMovie, doesn't it? PyMovie is free, and it allows you to put a little aperture on your star, and it will measure the light in here, and it has a bunch of different sophisticated ways it can do that. You could do a point spread function mapping. You could have it now even go through a so-called Fourier finder, where it stacks together tons of images and finds an accurate point spread function, and then finds the optimal aperture to use to get the best signal to noise.
We're seeing two sets of data there.
This is a comparison star.
Oh, okay.
Yeah. So usually you need a comparison star, especially if you got any clouds around. There weren't any clouds for here, and frankly, you know, I didn't really need that comparison star. But anyway, it's always good to put one in. And then often we also will put in just a blank sky, and then you'll see a whole bunch of scatter here around 0. And that's for the no star aperture.
What does the scale indicate?
Well, this is it again, and so this is frame numbers, so that's 20 frames from here to here. So we had, what, maybe 15 frames for the occultation, which lasted like 0.48 seconds. That was the total event. 0.48.
And is the 30 frames a second sufficient, or would it be valuable to run at 100?
Well, no, you got a camera that'll run at 100?
I've got
Sensitive.
these two.
Well, but can they record light levels like this?
Pixels as big as that camera.
Probably
That's
not.
a really
Yeah.
big chip with a small number of pixels, so
Yeah.
that must be like 9 micron pixels or something.
Yeah, 9 micron pixels. Yeah. Yeah, the problem is getting down. Okay, so if you need like that kind of time resolution, there's going to be very few events where you really need that kind of time resolution. Most of the events that Kirk and I do, we integrate 2 frames, maybe 4 frames even, sometimes 6 or even 8 frames if it's really faint. And it'll do that in camera and then dump out all of them, and then the software will average them and turn them into 1 point. So trying to get an event that lasts half a second usually is impossible. At least for the 14th magnitude stars I'm thinking about right now. But for a 7th magnitude star, yeah, you can do that easy. In fact, you could have used 100 or 200 frames a second and gotten better time resolution, but I don't have that camera. This is the camera I use.
Oh.
Vertical axis is counts.
Okay.
Yeah, it's a arbitrary number that's analog to digital conversion. So what did you get out of that? Well, there it is. So there's all these tracks that didn't see the occultation, nor did they see any little stuff around it, which would have been really cool. Suppose Kirk down here had gotten, you know, a little occultation. Well, then, moon, like, you know, there's other stuff out there. We know that the orbit of this thing does change due to the cometary outgassing effects. And, you know, we know it trails stuff because that's what the Geminid meteors are. So that would have been valuable, but nobody did see that. So there's my track. I managed to go right down the middle. And you can see the timing accuracies are pretty good, even though this thing's only 1 kilometer across. That's the smallest asteroid that we have done, except for Kirk and I also had a big expedition last year for the DART mission. You guys know about the DART mission?
Yeah, that's where they whacked it.
Yeah, we whacked it. Right. With Billy clubbed an asteroid. Well, we didn't do it, but no. But then after it's happened, we got to figure out what's the new orbit. And Kirk and I were part of a group that went out and got an occultation. We had to drive all the way practically to Arizona to get it, and it was great. It was a big adventure. We photographed all kinds of cool stuff the next day, and that was the first occultation that they had, the first data that we had of not just the main body, Dimorphos, but Didymos, the little moon.
That's what they hit. They hit the moon.
Yeah, they hit the little moon, and there we had enough people, and one guy said, "Okay, you know what? I'm going after the moon. My odds may be small, but you know somebody's got to go after that moon." So he got on a track that they thought the moon was probably going to be at, and he lucked out and got it. He had a bigger telescope. I think it would have been harder for Kirk and I because that event only lasted like 1/10 of a second.
It had a bigger effect than they thought, too.
And what does bigger mean?
What's that?
What does a bigger telescope mean? How much bigger? You're using a C8.
Yeah, we're using C8. He was using a C11, I think. Yeah. And you know, the square of the diameter is that'll give you at least a magnitude better. Question?
This is very interesting because everybody was successful because everybody who observed it, even though they did not observe it like occultation, they observed that there's no moons, no.
Yeah. In fact, okay, when I told you we had 43, Kirk and I both were at the moment have 43 successes.
Yeah.
A fair number of those are misses, but they're documented misses.
Yeah.
So we know the asteroid wasn't there.
Yeah.
And sometimes you have to risk getting a miss just to, know where it wasn't, because other people are in different parts of the path. Something else you'll notice here, look at Degenhart, there's like 5 Degenharts. Whitehurst and Moore, there's like 6, 7. So there are people who will go out and put out unmanned telescopes with gear at the back end, and they'll pre-point. It's like if we know, oh, that thing's going to go right across. If we put Spica in the middle of this field exactly 1 hour and 22 minutes and 5 seconds ahead of the event, and then just leave it there, then the star that's going to occult will drift through, and it'll be right in the middle when it disappears. So drift scan, getting a drift scan.
Tracking until the event comes along. Yes.
Well, no, they don't. There's no tracking at all. You get a small scope, especially if it's a big event like this with a bright star. You don't need a big.
Where it's gonna-
Yeah, you. In other words, you pre-point to somewhere that is where a bright star is going to track across that earlier, and you know exactly when it's going to do that, and you just make sure at that moment, okay, boom. But now you've got to do that for a whole bunch of different stars, because while you're doing it for this guy, now you've got to drive down the line for a mile or two and then do it again. And I'm amazed that people are as successful as they are. I've never tried it. I've been tempted, but I have a hard enough time just getting data myself. Yeah, just one. So.
I have one more question about the telescope. So you were using a C8.
Yeah.
You used a Celestron fast star and put the camera on in place of the secondary and run it at f2 instead of f10 or f10 times the focal length.
That's true.
Do people use fast star cameras on the fast star?
I don't recall at the moment anyone that I can think of or any event that I can think of where they're using a fast star, but it's a good idea.
Well, it would be a lot faster than putting a focal reducer on an f10, but it's also going to be a really
We actually,
big field of view.
Yeah, I actually bought a fast star system for Cabrillo, and we were going to use it to try and find exoplanets around bright stars, which are so sparsely spaced that you need really just a really wide angle field of view just to get comparison stars, to get the small dip. There was a brief window of time when amateur astronomers could really help in getting exoplanets back in the early days.
Transit.
That period of time when we could have done really valuable work kind of came and went about the same time that somebody broke in and stole our stuff. So that whole thing didn't work. But yeah. And it's just great being under a beautiful sky. So that's me at my site. I was actually near the entrance of the big solar farm that's out there at Carrizo Plain. Okay, so now here's another great event that we did. Quaoar, first exoplanet, or first Kuiper Belt object discovered after Pluto. And through occultations, it's now discovered to have 2 rings around it. And what's really amazing is that both of the rings are beyond the Roche limit. We've never seen rings around anything beyond the Roche limit. How do they get there? Are they stable? They shouldn't be stable. What are they doing there? So there was a lot of science interest in trying to map these. And fortunately, at the moment, Quaoar is going through the Scutum star cloud. So as long as it's still in there, we're hoping for more occultations. Kirk and I have actually gotten 2. And the best one was, well, the best. The one that was the most fun, because we got to go to Mira, maybe that's what I should say, was the last one, just this past May. But but Quaoar itself did not occult a star. However, the 2 rings were predicted to occult a star. So we're going to now look at that. So there is the path for Quaoar. And you see it misses us. We're down here. So, and there was a little bit of give, and there was a chance maybe, because we didn't know Quaoar's orbit perfectly yet, maybe we would get it, but I didn't want to get anybody's hopes up. I said, you know, we're really going after the rings. So there's Mira down here. But the rings were going to get it, so we thought, okay, this will be good. The duration of this event, long, 69 seconds. Now that's for the main body. For the rings, though, it would even be a second or two, which with enough signal you could do. So we thought, well, there's a decent chance we can get this. There's the prediction. So for Mira, we were predicted to get both of the rings. But the rings had only just been discovered. We didn't really know what their azimuthal density was. So it was important to find out. As it turns out, we did not see any significant dips. But that's a lower limit than on the density, at least at those azimuths where we were observing. But it was still a really cool night. We were given 2 nights on the Miroscope. So that's a giant roll-off telescope, if you don't know. And so there's this giant roll-off that comes off, and then there's a 36-inch, and we're going to see. The thing is literally draped with hundreds and hundreds of wires. Have any of you been to Mira and looked? Yeah, I know. It looks like a Halloween pumpkin that wasn't cleaned out. It's like just really... But everything goes to something. I mean, they're really getting as much science as possible. And in fact, Dan and Jean were both really interested when I contacted them to do this, because we're trying to add as much science as possible, because, you know, we depend on donations and we depend on gifts to keep our science going. And so far, we've been doing a lot of polarimetry, and this is brand new stuff. And so this would be really exciting. So yeah, come on up. And I've contacted them again, and there's another event, I'll show this at the very end of my talk, for Titania, the moon of Uranus called Titania. Titania is going to pass in front of a bright star on November 21st, coming right up. Visible in scopes you guys have, 11th magnitude. Yeah, contact me later and I'll tell you what I know. And there's Kirk. So now I got a grant and I bought gear, and one of the things I bought was another Wattec 910HX camera. It turned out to be a little later model than mine. It was better. Kirk's camera that he has on sort of semi-permanent loan is better than mine, which is probably another reason I'm going to claim that he does a little better than me most of the time. So we put him, I said, okay, well then you should be on the 36-inch. And I'm going to be down here on the little 14-inch plane wave. That's my gear table down there. Kirk's got the big scope. But that's okay. I'm not complaining. Kirk got great data, yeah, but there's me underneath all the wires, lit up by my data screen. And yeah, they got a brand new 14-inch Schmidt-Cassegrain plane wave, and so we thought we'd record it twice, and that way if we had stuff that might be, is that the signal to noise good enough? You both get it, it's like, okay, that was real. This is a screen for PyMovie. So PyMovie is this Python program written by Bob Anderson, and it allows you to reduce these events. So you put an aperture around the star. This is the target star, 15th magnitude. Yeah, but on a 36-inch you can do that, and we had perfect weather, no moon, it was great. Well, a little teeny moon, I guess, not much. And then some comparison stars. And if you turn them yellow, they're tracking stars. And so what it'll do is this thing wanders around, it'll track and it'll drag along your aperture on your star as well, because what you don't, and while if your star hasn't disappeared yet, it will actually moment to moment track that, just won't go too far. And then when the star disappears, it says, oh, it's gone. Okay, I guess now I'll just be slaved to the tracking stars, you see. And then when it comes back, it says, oh, okay, I'm on my own now. And it'll track it. It's really smart software. He keeps improving it. It's really good. So there's Quaoar, comfortably above 0. So I know you if you try and do a 15th magnitude star down here, it might hug zero so much you can't tell. And here's our reference star. And there is weird stuff that goes on, and there was a little teeny cloud, we think, that went across there. So what you can do is do a reference star, and you can smooth it over whatever interval seems like the right interval. So this is the smoothing that Kirk used. And we know when the rings should have occulted, and there's nothing there. Nothing that we could claim. So that would have been great, but we are still part of the team here. See, Nolthenius and Bender's, and there he is, Kirk Bender. We did another occultation, you see, by Quaoar in 2022, and on that one, that was great because they had they had tracks for like the Keck telescope and the CFHT and then there's Kirk Bender and Rick Nolthenius with their 8-inch telescopes with this faint little star. Nobody else even dared try it, but we're pretty good. We've gotten pretty good, and we're able to pull it out, and it showed perfectly the ellipsoidal shape of Quaoar and how it fits perfectly with the angle of the rings. So the rings are in the equator plane. It was a great visual. Now, for that second event that happened just last May, that we actually didn't see the rings, there was another event the day before by the big well-known asteroid Eunomia. But it was a bright asteroid, and the target star was dim, and the drop was only 1/10 of a magnitude. 1/10 of a magnitude. But we both got it, given the signal to noise that we had, and the duration. It was a long event. It lasted a whole minute. So with a minute to work with, you can detect some faint stuff.
See how the reference star data fits in there. Is it actually?
That actually was used to adjust each point here according to whatever clouds might come or seeing events, blurrings.
So if that wasn't done, then your occultation...
It probably wouldn't change much. No, the occultation would still be there, I'm sure. But you never know. I mean, like something did happen here. I don't know what it was. Was it a bump? Was it a cloud? We're not sure. But anyway, you can see this here, and you might have thought, oh, is that a little moon? But then you look here and say, no, it wasn't a moon. It's a bump or something. Sometimes you do. Or not. Could be a cloud. I'm not saying Kirk bumped it. But that does happen. It does happen. Yeah, it happens more often than you want. Okay, the Lucy mission, 12 years, 10 asteroids, 1 spacecraft. I mean, this is manly astronomy. And the prime target for Lucy is this, the largest of the Trojan asteroids. It's called Eurybates. And this was another great adventure because Eurybates was predicted to occult a kind of a faint star, 12th magnitude, but the track crossed Mono Lake. Now it happened to be on a night when a storm front was moving in, and all of California to the west of the Sierras was cloudy. But I really wanted to go get this, okay, and be part of the recon team, which is a series of observers who've been given telescopes all along kind of the California-Nevada border. But they're amateurs, and they often don't get data. And I thought, well, Kirk and I could really contribute here. Let's do it. But, it was on class night. My asteroid observing class was Tuesday night. And I thought, God, I'm going to cheat out my students by just saying go home. And then I thought, they probably won't care. And I said, well, I'll only do it if, we really have to go. And so I'm in my office, which is right next to the classroom, and I'm watching the update on the weather moment to moment. Oh, this doesn't look good. Oh, that's a little bit. Oh, no, this new one doesn't look so good. But when you get your inner child involved, yeah, I've learned that when he gets involved, you've got to give in, unless there's some really good reason not to. And so The last weather report looked more promising and said, okay, we're going to do it. And I called up Kirk and I said, Kirk, be at my place in 15 minutes with all your gear. We're packing it in and we're going to drive to Yosemite. We're going to go down to Mona Lake and we're going to set up and we're going to get this thing. Which is what we did. But the cloud forecast still looked grim. So this is all solid clouds here. And then you get over the mountain range, and at Lee Vining, it was like, no, there's some blue there. I've got a page, by the way, maybe you guys should know about. It's on my main splash page at the very bottom. It says Weather for Astronomers. And it's got all kinds of links to great sites for like close in, like fog tops and cloud forecasts, detailed cloud forecasts that go hours, days, and even a week or two into the future. And they're really, really helpful. So this is where I got this one. And I said, we're going to go for it. But we got down, without a whole lot of time to spare. It was really windy. The clouds were coming over the top of Tioga Pass and then dissipating some, but there was like big fat clouds and they were moving fast. So you couldn't really predict where you needed to be. And there were already people at some of these sites, but not down here. So I said, you know what, that's close enough. We're going to set up somewhere in here. And I ended up setting up Kirk right here on this track. And I took this one, which fittingly enough went through a cemetery, an old West cemetery. Cemetery on the north end of Mona Lake. Yeah, you've been there?
Oh, yeah.
That's where I was, amongst the headstones. And so we're setting Kirk up, and we just, we like to take shots to document because, you never know when you're not going to be able to do these anymore and you want to look back. I do these for the memories. There's me at my spot, and if you've been to the cemetery, there's like a big line of trees before you actually go into where the gravestones are. It's pretty informal. I mean, anyway. Fast-moving clouds everywhere. And would we get data? So we're approaching the event. I'm all set up. I've got it on target, and I can tell this cloud is coming in. And I'm looking at my watch, and I'm looking at the cloud, and I'm saying, you know what? It's going to be a photo finish. I don't know who's going to occult that thing first. Is it the cloud or is it the asteroid? And I just barely got the event before the clouds came in and took everything else away. Wow. Half a second.
Oh, geez.
and Kirk, unfortunately, was clouded out. So,
That was worth it.
but it was worth it because look at what we got. My D was the only track that we got on the far side of the asteroid. So this defines now the shape and size of the asteroid. And this is the prime target for the Lucy mission. So this is really valuable. Yeah, and then we celebrated the next day by going to a pub and drinking some beer and pizza and photographing Aspen. And this is in October, so it was a fun trip in a lot of ways. Yeah. So.
The pub in Mammoth?
Well, this is June Lake here, and then that's in June Lake also. But we also got to text all the other people who observed, and so it was fun. We weren't sure we could get back across the mountain. It started raining when we were having our beer, and we knew it was going to be snowing up at Tioga, and we kind of looked at each other and said, I think we should get on the road. We did make it across. Binary asteroids, okay, so Kirk and I have been involved in 3 of those, and maybe more. We're not totally sure yet. Not these, although we did get an occultation by Antiope, but only of 1. And that was actually on one of my class trips, Astro 25 to Stanislaus River. In May of 2021, Dave Galt and Peter Nosworthy in Australia, they have permanent observatories, and they saw what was clearly a double occultation. Both of them did. It was clearly a moon. So both of these satisfied the false positive test with plenty of room to spare. And word went out, and then David Dunham contacted me and said, you know what, there's another occultation by that asteroid in just 3 weeks. And it crosses down in south central California. And I thought, wow, that would be great. And then I looked at the time. Oh, it's 4 a.m. and it's on a Tuesday morning. And I thought, should I do that? And of course, once you start thinking about it, then it goes to work on you. And of course, yeah, we got to do it. So Kirk's always game when I call him up and let's do these things. And so we did. And we got an even better observation than the initial one. So we verified that it really was a new moon. It's the first actual discovery of a moon by occultation. There's been other moons of asteroids, there's several dozen, but none of them by occultation. So there's even a prize that was awarded, but so far Kirk hasn't seen any money yet. I don't qualify because I'm more of a professional, but Kirk would qualify. But he confirmed, he and I confirmed rather than discovered. So anyway, I don't know. I've never heard about any money, Kirk, so in case you're wondering. Maybe they didn't tell me, right. Okay, and then the DART mission. So I kind of already told you about that. I set Kirk up, well, I set up here, and I set Kirk up on this line just off screen here. But we were like literally just a kilometer away, really close. It was out in the middle of nowhere. It was out in the Mojave National Reserve. So it required high precision timings and high precision placement. But the star was reasonably bright, as these things go, 11th magnitude. So we got to take data every frame. We didn't have to integrate frames, and then we could even reduce the data using field mode. So these are interlaced videos, and so if the software will allow you to study the even lines and then the odd lines separately. And then you got 60th of a second instead of 30th of a second time resolution. And for a bright enough star, you can do that. And I did do that for this one. Yeah, it's a little unfortunate that the 3 highest value events that I've talked to you so far about, Kirk didn't get data on any of them. But he has, in general, been a better observer than me. And the problem is, I don't know if you guys had this problem, but there's the barrel plug that powers the 8SE telescope, and also a barrel plug that does the Meade telescopes, the LX200s, little 2.1 millimeter. But the center of those barrels is not identical. And if you try to power a Meade with a Celestron one, it won't go in at all. But if you try and power a Celestron with a Meade one, it will go in. And you won't notice that it's a little bit sloppy. So there was some moments of intermediate power contact, and as soon as you lose power, all your guiding is gone and you have to start all over. And he did that a couple of times, but then the last time it was too close to the event.
Yeah, the connector with the large hole is for a larger amp. So you can put that one with the larger hole in the socket with the smaller prong in it, and it'll fit most of the time. But if you jiggle it, it'll lose connection, and then you've lost your alignment. So
that's the difference between a 5.5 and a 5 millimeter.
I would open it up.
All his
I
proprietary.
did the same thing just recently.
Drop some solder in there, and
Put a 5 millimeter on it.
or just get the right one. Unfortunately, when you're buying these things, it just says 2.1 millimeter barrel plug, and you don't really know until you bought it. It's too late. And both I've had the same problem and Kirk, and then Carl. We've all had this problem, and learned the hard way, and then had to scramble to try and find the right plug.
it's good
Look.
that you can't put a low amp plug into a high amp socket, though. That's a good thing.
That's a good thing, right? But I just want to point out, look, 0.24 seconds. That was how long the occultation was. It was long enough that as I watched it, I could tell. Oh, I think it disappeared. I think I got it. But you got to reduce it. But that was still, 1, 2, 3, 4, 5, 6, 7 different fields. So it was actually ended up being pretty high precision. And so there it is. There's my track, and we got 2 others who also got the main asteroid, and then one guy got the moon. So that's Dimorphos. That's the thing that got hit by the dart. And so we're badly wanting to get more and more of these, but it goes through periods when the occultations are so short that nobody can get them. And you have to wait for periods when it's going slow and it's in a good star field, and then you can get occultations again. That's supposed to happen again in 2024. So we may get some more, but this was a year ago now, and there hasn't been any since.
Go fast and sometimes go slower? I mean,
Yeah, it depends on where it is in its orbit, but also depends on where it is in retrograde motion. Maybe going through the stationary point and then retrograde and then,
perspective.
yeah. Yeah, when it is near stationary point, those are the best to get, because now your spatial resolution's really good, because your time resolution translates to tiny space. And then, so Kirk recorded this, and we had to argue with the auditors to even treat it seriously, because okay, this is being recorded, so I won't anyway.
There was a win?
I went ahead and I calculated what is the depth as seen from Kirk's data, and what was the depth seen with the actual true occultation, and they're the same, which is what you would expect if it was a moon. Same depth for each one. Is it real? We don't know. There's different points here because there's a comparison star in here also. We don't know. We need confirmation. So I'm not trying to claim that he discovered a moon, and Kirk's certainly not somebody who will do that. But I'm waiting to see whether there's another Repsolda event. And it has at least been added to a list now, so that if there is another event, then the word will go out. This is a more valuable event. Please try and get out other IOTA members and try and get this. And then the last one that I'm going to show before I finish this up is Pluto, because this one is a bit relevant for the Titania occultation coming up. So this was in 2018. It's in my 2018 list, although I have in my memory. You were there. Was that 2019 or 2018?
Gosh, I don't remember.
I hope I didn't file it into the wrong year. It's under my 2018 stuff, but I have in my memory it was 2019. Anyway, there was a bunch of people who signed up to get it. The star was not bright. It was pretty dim, 15th magnitude, but no, I'm sorry. Pluto was 15th magnitude, but the target star was more like 14th. So it was a deep enough event that you could see it. It wasn't a complete drop to zero, but it was pretty deep. 14th magnitude, though, with a 8-inch telescope, pretty tough. So we contacted our go-to man, Cruz, and he went through the extra effort and I think some expense too. Didn't you have to?
What expense?
Well, to get checked out on the scope or become a member or something. I don't know.
That I was always a member.
Okay.
So there was on the board, so I.
Yeah. Well, that's what I thought, but then I thought.
Yeah.
You had to.
Status is it? I don't know if it was,
at
that time it was extra. Yeah.
I think you had to pay
$30,
extra $30 came in there somehow.
That's,
But that's just part of science, right? Write it off on your taxes, I hope. So the northern limit of the event is the blue line, and this is the 1 sigma error bar. So between the center line's way down. Pluto's reasonably large. The nice thing is that here we were inside the path, so we were going to be able to see it drop and stay down and gone. But you also get an extended period of time when the atmosphere is going to be affecting the star. Now, the density of Pluto's atmosphere is incredibly low, and so I didn't know whether we would see anything, but we did. So there's our team, and there's the 30-inch scope. It's Oh yeah, no, it's equatorially mounted and it tracks Fremont Peak. Yeah, this is Fremont Peak, not Mira.
It's not a go-to scope. But
It's not a
nice.
go-to, but it'll track. So yeah, it's true. I had to muscle it around. We had to muscle it around. Actually, that wasn't that easy, as I recall. We had to muscle it around to get it to the right place, but we succeeded. Here's all our gear, batteries. There's me. I think this is a shot from Kirk. Did you sandwich a couple of shots together to get this?
You're out of focus, so.
Well, yeah,
Sky's
but-
in focus though. Nicely.
Anyway, it's a nice shot. And Pluto, you could tell, is in the Milky Way. Good. More occultations. And we got it. And we're right up here near the top. So Nolthenius and Angelos and Bender is off the edge there, I guess. Paul Maley, David Dunham, of course, John Moore. So these are a lot of the big names in occultation astronomy. And the cool thing is we had the biggest telescope by far, and well, okay, so that's the target there.
So what were you trying to do with Pluto, with all this?
What we're trying to do with Pluto is see if we could measure the atmosphere. So science-wise, what we wanted was to know, okay, so we got close-up pictures and atmosphere data of Pluto when the New Horizons mission went there in 2015. This is now 3 or 4 years later. And Pluto is getting farther from the sun. And it's kind of late summer, quote unquote, and we wanted to know when is it going to transition to a point where the atmosphere begins to freeze back onto the surface. And the only way we're going to be able to do that, unless we launch another mission, is with occultations. That's a comparison star, and you can already tell, look, gradual DNR. The density of the atmosphere had been detected on earlier occultations.
Okay.
Yeah. But of course that was earlier in the season, so we haven't seen a full orbit of Pluto yet. I had just a expanded view that showed that there was 20 seconds of fading and 20 seconds of brightening. And so we were able to see occultation by the atmosphere going up to extremely high levels. And the density of the atmosphere of Pluto is like 13 millionths of the Earth's. So I thought, well, geez, you can see the tiniest, the density is extremely low. It's like,
Sounds lower than Mars.
oh, it's way lower than Mars. Mars is 1%.
Oh, okay.
This is 13 millionths.
So Bill was just saying that
There isn't.
the path around the sun, it's like 290 years or whatever it is.
248.
Huh?
248, yeah.
So is this the first time it's been oculations been done?
No, there have been other occultations seen. But this is the first since,
But
by
from the Earth.
yeah.
From the Earth.
Well, Pluto's been kind of in the Milky Way for a while now. It goes really slow. And there have been other occultations seen. Not a ton, but a few. And so we had seen the atmosphere. This isn't the first detection of the atmosphere. I don't want to give you that impression. But it's the first detection of the atmosphere after the New Horizons mission. And it's at a point where we have been seeing the atmosphere getting thicker, and we know at some point it's got to start thinning out. So we want to learn something about Pluto's climate. And that was the science importance, yeah.
It was closer to us, to the sun than Neptune for about 20 years, between 2000 and 2020 or something.
You know, between 1979 and 1999.
Okay, yeah, right,
Yeah. In 1989 it was closest.
yeah, that's right.
And so now it's farther. But the reason that it's really interesting is because Titania is coming up in like 2 weeks. And look where we are. We're down here in a very similar path like Pluto. We're down near the edge, but we're definitely in the path. We're pretty, well, we're almost certainly in the path. The odds are high. And I showed all this to the Mira people, and again, they're really interested in having us come. Now, it's a Monday night, so I teach a 3-hour Monday night class, which I'm going to have to, I don't know, I'll turn into like an extra credit, like if, you know, one person from the, we can't take a lot of people, but, because I want to get a van. I don't want to drive up that road. It's a terrible road. And but I want to do it. And I haven't actually gotten confirmation from Kirk yet. Are you game to? Kirk's in. All right, yeah. No, we had a good time last time. And this could be the discovery of the atmosphere of Titania. We don't have any missions to Titania. We don't have any occultations yet. We had Voyager 2 fly by. That was it. That was in 1986. Primitive stuff. We didn't have the ability to detect any atmosphere. So this could be really interesting.
So Uranus is about 6th magnitude or 7th magnitude. And so you have this very bright planet, very close to a 12th magnitude star.
Yeah.
So that's going to be tricky.
Well, that's why you want a long focal length. That's why we want to be on the big scope. But even from here, it's not horrible. It's like, well, I calculated it somewhere. I think it's like 15 arc seconds away from the planet.
Okay.
15 arc seconds on an 8-inch, you would not want to use the focal reducer. You'd want to take that off. But then you could probably get it. There was another event, a much dimmer star, Neptune. Neptune's moon, no, it wasn't Triton, it wasn't the moon, it was the rings.
Oh,
So Neptune occulted a star, and the rings were going to be 1.7 arc seconds away from Neptune. And I started thinking, well, maybe we could do it, and I started calculating, and I said, I don't think we can do it, and I had to tell the Mira people, I don't,
the atmosphere
and they finally said, no, let's skip it. So we did. That was a week or two ago. Yeah, recently. So these things do happen. That is my last slide. I don't know what will happen when I push this to go back upwards.
Boom.
Oh. Yeah, I guess that's my last slide.
We did do the Titan occultation.
Oh, we did do Titan. I didn't put Titan in here.
Good, interesting atmosphere stuff.
Yeah, that was the slides that we missed on Pluto. So there's point-to-point scatter, but you can see in the Pluto occultation data that we got that there was coordinated ups and downs in there as well. And those were confirmed to be actual atmospheric layering effects. So going through, the atmosphere can do converging and diverging, and it'll brighten and dim, just like you see the sun do when it goes through its layers above the ocean. And we saw that even much more in Titan. So Titan occulted a bright star 2 years ago now, I think it was. And we're also near the northern limit of that. But to make sure we were in the path, we had to drive south to Pisces, which is where we set up. And Kirk got the best data. I got good data of only 1/2 of it because I was not allowing enough time. But we both could see the layering in the atmosphere. It was a bright star. In fact, it was such a bright star that there's not going to be another one like it for the rest of anybody's life in here, I think. So, yeah, you got to grab them when they happen. Questions?
Corollary to layering is like tropopause, stratopause in our atmosphere, maybe temperature differences or density or whatever, something.
Those are pretty big, thick layers in our atmosphere. It's more like these are smaller scale. And in fact, I remember seeing images from Pluto, and I'm not sure what the source of that data was, but it was showing aerosols in Pluto, and you could see the layering. You remember those images? Yeah.
I think it was a backlit from New Horizons.
It might have been, yeah, a backlit image that then they color coded to bring it out better. Yeah. So you can do a lot with occultations if you've got good data, and they've got the software now to help you analyze it really well. Yeah.
Speaking of Pluto, I'll just mention, has anybody read Chasing New Horizons, the book by Al Stern? It's
Alan Stern?
The whole mission of going to Pluto. But it's really a riveting story about, it's amazing that it worked.
Well, we had a Pluto Palooza at Cabrillo College after that. Jay Friedland put that on for a bunch of school kids, and I, helped them put it on, and oh, that was fun.
I highly recommend
Kids
the
were
book because
so excited.
it just takes you through the whole journey of the idea of going to Pluto and then the actual execution of doing
What was it called?
it. Chasing New Horizons.
I saw some other slides in there. Did you not want us to see?
I wanted you to see them, but every time I get to one slide, it just says I don't want to go any farther. So see, now I'm pushing the up arrow and it's going
Sunset is an
And it's
down.
still going down?
Yeah.
That's
Earth, the planet, is getting in a way of the sun,
I-
which is a star. It just happens to be really. We see a lot of stuff. happen.
Maybe it's, I don't know, but that's okay. I'll just push that arrow. So yeah, okay, now
No equipment required.
I would like to show these, yeah. So this is our equipment. Now these are 2022 prices, so of course they're all obsolete. Double them all, right? Yeah, Celestron 8SEs now are like $1,700 or something, I think. I really like them. I like them a lot better than the equivalent LX200s, the old LX200s that were also 8 inches. Because the electronics on those Meads was terrible, not protected at all, and you just look at it wrong and fuses blow and capacitors blow, and you've got to then send it back east to find somebody to fix it.
Telescope you use for regular photography?
Oh, yeah. And it's
It's just that it's really good for occultations.
well, it's lightweight because it's got a single arm.
Okay.
It's not a double arm system. It's altazimuth. So it's not good for photography unless you're just going to do planets or the moon. You wouldn't want to do long exposures through it. But, that's okay. I do that with something else. It's lightweight. It's got plenty of power. It's never, had trouble. Not like the Meads. So I've been happy with it. And they're, relatively cheap compared to a lot of scopes you can get.
So it looks like the telescope and the camera are the big tickets.
Yeah, the camera's pretty expensive, $700. The Q70 eyepiece, we just like it because it's got a wide field of view, but you could, pick any eyepiece you want if you think that you can, you're good at star hopping and patterning, or you want it running through a plate solver. I don't do that, but some people like to do that. A diagonal, because otherwise you're trying to look straight through, down, and that's not good. And then the camcorder, these used to be like $700 20 years ago, but now you can find them on eBay for cheap. And in fact, there's still plenty of IOTA people who have them. And I got a couple donated to me, which I haven't even used yet. And so this should not be a big problem. These are lying around, as long as they still work. But if you don't want to do that, you can just bring a laptop, and then you don't need this. And you also don't need, probably some other stuff. Anyway, I never went that route. I don't like bringing a laptop out into the field. The video time inserter is also a little pricey. Toolboxes.
Does that just put it in the header, or is it that actually put it in the film, in the image?
It stamps it on every frame. When you play it back, you just click it, and any video playback you'll see along the bottom.
So it's in the actual picture.
The time stamp for every field, even. So it's got the time, and it's got the time for the first field and the second field, and the first field and the second field.
So it's visual
It-
in the image.
Yeah, so now the software though will actually visually interpret that. You train it by saying, okay, now you're looking at a 1, now you're looking at a 2, now you're looking at a 3. And you put little boxes around where it is, which is going to be reproducible. And it takes 10 or 15 minutes to train it, but then it's trained. And then you just run it through the software and boom, there's it makes this giant Excel file, and the Excel file has the timestamp for every frame and the photometry for every star that you decided to put in. You could do as many stars as you want. And you can do them in different ways. In fact, there's so many choices that it's actually a little baffling. And sometimes when you're doing a really difficult event, you're trying every possible thing to try and get it to pass the false positive test. And so it's made me hesitate on doing like super difficult events, just because I know I'm going to waste so many hours trying to reduce it that it's like life is short. But the event tonight, which is at 11 o'clock, and it's up near the, what do they call that? The Pulgus Water Temple, the, yeah, up the peninsula, just off 280. Crystal Springs, yeah. That's at 11:06 p.m. And the star is 12.7 magnitude, and it's going to be gone for 9 seconds, which is a good long time. And it dips a good more than half. It doesn't go completely gone, but it dips like a full magnitude. So with skies like we've got now, it should be straightforward. And I thought, gee, why don't we do it?
What
So
asteroid?
Yeah, I was gonna say, what?
it's called Pentethlia. They have weird names. I don't know whether they're like first and last names of old girlfriends that have been, there's so many asteroids now. I've got an asteroid named after me. So they ran out of Greek gods long ago. And so, yeah, and I always have trouble because if I spell the name wrong and yet I get it all loaded up, then it's like I can't change it because I get, all kinds of weird Windows errors. And so I got to take the time and, okay, exactly does this look like? What's the words? What's the letters? Before I make the folder that's going to have all
What's
this.
the size of this asteroid tonight, and has it been occulted?
That's just what I.
I've not seen, the name is totally unfamiliar to me. There is a way to check whether it's had occultations before. I will say that the rank of the event looks good, meaning the uncertainty in the path nominally is small. Our odds look good. Normally that means, there's probably at least a couple of occultations that have been done for it. But I don't know. I know I've never seen it in my predictions.
Main belt? Main belt?
It's a main belt, yeah. It's not a super high value event, but as far as I know. We could discover a moon, and then all of a sudden it will be important because now you get the mass and the density and all that good stuff. So I'm trying to build another unit. We've got 3. I've got a 4th that's under construction. We've got the telescope. We've got really all the gear. I just need to do some more soldering and building a knock box for it. And actually I have enough, I think, even to do another unit after that. And all I lack is people who want to go out and do these things. So we're trying to get, more interest because you've probably looked at all the planets plenty of times and said, yep, that's it. It looks the same.
Okay,
I'm
what's
looking for
next?
something new and different, yeah.
Next.
So I get a kick out of doing something that actually has some value, and you get to play around the computer and you see graphs and you get to do math and think about math, and I like that kind of
So
thing.
going back to what you said.
And Kirk's a programmer, so he likes that too.
I really see what you're doing and others that do this for the value of protecting the Earth, or just being in context with all this and being able to supervise what's going on out there to see if anything's getting too close to us.
It's fun. I do them because they're fun. They get me out of the house and I get to go drive somewhere I probably haven't been before, and
It's called risk management.
and you take a risk. Sometimes you go out there and you get clouded out. Sometimes you go out there and you see a miss. Sometimes you get data and then you come back and you try hard to reduce it, like recently. And it was just too tough. It's like, why did I go after this? It's 14th magnitude. It only lasted half a second. You know darn well it's not going to pass the false positive test, even if you're in the path. I'm trying to discipline myself to not try events that are like, but a man's reach should exceed his grasp.
I've read that somewhere.
Somewhere. Somebody famous said that, some poet.
What is the threat level of your asteroid?
My asteroid. It's a main belt asteroid. However, so Kirk and I went out to see the eclipse in Nevada, and that was fun. And part of that was we got to do an asteroid occultation on the way home, just north of Mammoth and south of June Lake. And while we're out there, I'm thinking, it's really, really dark. Kirk, can you find on your Sky Safari, where's Asteroid Nolthenius? It was in Aquarius, which is like in opposition practically. I said, well, shoot, I should try and image it. What's the magnitude? He said, well, it's 18.7. And so my first reaction was, on an 8-inch? Give me a break. But then I thought, now how far will this WATEC integrate? Well, it'll go up to 256x, 256 fields that it will integrate before it dumps. So you only get one set of readout noise for 256 fields. And so I said, okay, well, 256, how many magnitudes is that going to give me? And then what if I go through the finder procedure and it stacks, and you could stack as many as you want. I said, gee, I think if I did a couple of minutes of data, I might just be able to get it. So I did. Except I didn't have star fields that were good enough to make sure that I was on target. So what I did is I got the coordinates from Kirk, and I just told it, after the occultation, I said, okay, just go there. And I'm just going to spend a few minutes and integrate there, and then I'll just hope to hell it's on there somewhere. So I did that, and a couple of weeks later, finally I got around to doing it, and I found, oh, you know what? It's just barely below the top of the frame that I integrated. And then is it there? Oh, there's something there. I think there's a smudge. Well, let's play with the contrast range controls, and I said, yeah, I think that's it. So I calculated it was on the ragged edge, and I think it was. It was super dark out there, super dark. Now, you wouldn't want to actually go for an occultation like that because, minutes of data, your time resolution's going to be gone. But I have gotten 14th magnitude events. Kirk's gotten a 15th magnitude event of, what was that Kuiper Belt object we got up at Lick Observatory that night? I think you were the only one who got good data on that. What was that? Anyway, it was some new Kuiper Belt object. And the star was really, really dim, but it was super dark up there because of fog. So why'd we go way up to Lick? Because the fog was coming up, 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 and we kept receding. And, get back in the car, we got to go higher. And we almost were at the top before the fog stopped coming up anymore. But it made it really, really dark. So yeah, we actually got good data. Kirk got good data. My data was...
So, a different topic. You've got a lot more years in this. I've almost come to the conclusion that I should just ignore all weather forecasts.
Yeah.
And just show up.
Oh, well, I don't know. Weather forecasts have gotten better and better, in my experience.
Okay.
Not in
What's
yours.
your
Well,
best source? I mean, you've got to. I look at your web page, but
yeah, I know. Can we bring up a web page?
Yeah, you can do it, but
Probably too hard.
the Wi-Fi is right there.
Oh, well,
You had a slide with the weather
Never.
map on it.
pardon?
You had a slide with the weather map on it.
Yeah, you saw that yellow and gray map that I had
Yeah.
for one of the events, and that's one of the sites. One of the ones I like because it really shows you in detail where the clouds are going to be. And in my experience, it's pretty good.
okay.
It'll tell you like a day in advance, where's the cloud boundary going to be? Are we going to be in it or are we going to be out of it? And it actually is pretty good.
Weather.us.
Yeah, weather.us. If you just Google Rick's Astro page,
Yeah,
the
we
top
know
link
where
will
it's
be my web page. And if you take my web page, there's all these courses and whatnot. And then down at the bottom, the very bottom, weather for astronomers.
you want the detailed cloud
Is that in that
forecast?
email that Jeff sent out?
Yeah, I've seen it.
The bottom there.
I think we've all got to your webpage.
Yeah.
I think we have, yeah.
Yeah, and I assemble anything that looks useful and I've found useful, and there's a bunch of stuff on there. And it'll show fog. There's different ones. Some will show fog. Of course, there's infrared maps and there's long wave maps, and every wavelength you can. Yeah. So you look at tonight. Look at how yellow that is. Clear. We got clear skies. That's why we're psyched about getting this event tonight.
Right, well, that's a great tip. I'll look at that and try to get better sources than I've used.
You're not listening to the guys at 11 o'clock, are you? Those guys are
No.
bozos, yeah.
No, but I mean, it's the standard stuff, but I don't know how many times in the last few months it looked like clouds are going to, be over the airport, and I said, well, I'm going to go up there anyway. Go up there and blue skies.
Bonnie Doon's always
Oh, well,
come through.
yeah, what I'd really love to see is a site that just gives you the exact cloud, the fog tops.
That would be, yeah.
The best I can do is there is a site that shows fog, and it shows it in real time, and it'll zoom right in on Monterey Bay, and you could see where it is. And it doesn't tell you the future, but you can watch it trend, and then get an idea, is it, am I going to be okay up there or not? Yeah, usually if it's above the airport, then I don't even try, because that's the last really good spot you can go.
Well, I've been trying to use Astrospheric, and that seems to be okay, but even that is.
Yeah, I don't use that one, but I heard people say they like it. Uh-oh.
Got a commercial?
What's this? Are we still taping? Uh-oh.
So you guys driving up?
True crime. Yeah, that was the plan. I got all my stuff loaded. Kirk brought all his stuff. So normally we carpool up there, and
Any other questions for Rick while we turn it over?
we should.
I got an observation. Ever since I found out about Tycho Brahe and all the data he came up with in Denmark, that Kepler used, I just can't believe.
Plus or minus 1 arc minute of accuracy.
In clouds all the time.
Now, how did he get such good accuracy?
You have a bunch of people working for you.
Time? No, it is time. Yeah. So it's like in the movie Interstellar. It was gravity. No, it was time. He had good clocks, and he had a transit instrument, and you could time when it went behind that little razor, and time it accurately enough that turned into, things move slowly across the sky, and so you could get the right ascension very accurately. Yeah, plus or minus 1 arc minute. It's the size of a lunar crater, and it's all naked eye observations. Yeah, I know he's an incredible observer, but not a good theorist, not a good mathematician, and kind of a weird character in other ways I understand.
Data for other people to use.
Yeah, but he wasn't even very generous, for as I could tell, about when he was going to die, to give it all to Kepler, because his errors were like, no, he was just supposed to be the calculation guy. We want our guy to be. Well, they both got justified fame. I don't know. Well, the way I read it was the data, quote, fell into his hands. So I'd like to think that Kepler finally stole it, because Brahe's heirs were not keen about having it go to Kepler.
Anything else?
Thank you.
Are we going to see what kind of equipment you use, or?
Oh,
It's probably out in the car, right?
yeah, I think Kirk got here late, a little bit too late, but you saw pictures of it.
Yeah.
Yeah, I guess we didn't get that set up.
I think he's got another video on your YouTube channel.
I do have, if you go to Cabrillo Astro, the YouTube channel, Cabrillo Astro, I do have a video showing all of our equipment and me setting it up. It was sort of an educational video for students, for me, my students.